Hello and good day, pre-algebra. We are covering CO69 today, which is about experimental probability. Okay. Yesterday in 68 with theoretical, we did a couple of experiments. Okay. We flipped a coin, each of us flipped a coin 50 times, and we rolled a die 120 times. And we said, well, here's what should happen, right? Theoretical probability is what should happen, whereas experimental probability is what actually happens. Right? When you actually do it. When we actually flip a coin 50 times, what should happen is you get 25 heads and 25 tails. But today we're going to focus on what actually happened. Okay? So this first part is all going to be different for you. What were your individual results from flipping that coin 50 times? Whatever you actually got, write those numbers in there. In theory, they should be 25 and 25, but only like 2 or 3 people actually got that. Okay? If you weren't here yesterday and you didn't do this part, you can just skip this first line here. And then the class results. This everyone can do. I already forgot what our class results were, so let's go back and look here. Oh, geez. Hold on. Clear that. Okay. Our class results, 455 heads, 495 tails. So 455 and 495. Okay. In theory, and again, we had 19 people do this, so our data is a little bit different than what we originally planned on. But in theory, we should have gotten 475. Okay. So we didn't hit that exactly, but after 950 rolls, only being off by 20 is pretty close. I mean, we had some people get 30 and 20. I mean, there are some pretty large disparities in results there, but all in all, it came up pretty close. So compare your results to class results. Which was closer to the theoretical probability? Well, they're actually both 20 off, so they're both the same distance away. But our results, class results, are below the theoretical probability. Right? Because what should have happened is get 475 heads. That's what we were focusing on, the heads there. What actually happened is we got 20 less. So our results were below what should have happened. If we were focusing on the tails, our results would be above, right? Because we got more than we should have. But our focus was how many heads we would get, and our results were below. Okay? Yeah. Theoretical probability. Sorry. Theoretical. If you they're right up above it here too, if you want to look at the spelling. I will try and write better in the next section. Questions on this? Other words that are illegible. Okay. While I scroll down here, go ahead and fill in your individual results for rolling the die. And again, this part is all different for each of you. If you weren't here, you can just skip this part. And theoretically, you should have gotten exactly 20 of each. And when we looked at the overall data and highlighted how many people actually got 20 of anything, there were 2 people here, 3 people that got 20 on 4 of them, right? But overall, very few people got 20 of anything, even though that's what theoretically should have happened. Our class results. Let's go back here. We've got 322, 388, 391, 322, 388, 391, and 392, 407, 374. 392, 407, 374. And theoretically, based on 19 people, there should have been 380 of each, which, like we said, after this many rolls, our 2s, our 3s, our 4s, and our 6s, I mean, that's pretty good. That's pretty good. Okay. Compare your results to the class results. Which was closer to the theoretical probability? So go take a look at yours. How many of your individual results were exactly 20 or as close to 20, as we kind of had here? Those of you that got 4 20s, your results were closer than the class results, right? If you don't have anything within like 3 of 20, or you've only 2 results that are like within 3 of 20 or 2, then your class results are ultimately closer. But which one shows which one's closer to the theoretical probability? So this answer is different for all of you here. But for most of us, the class results were closer. And as I said, that's because of what's called the law of large numbers. And the law of large numbers is this. The more times an event is tested, the closer the experimental probability. Look how good my handwriting is here. Is to the theoretical probability. So the more times you do something, the more times an event is tested, the more times we flip a coin, the more times we roll a die, the closer what actually happens gets to what should happen. You might flip a coin 10 times and get 10 heads. It's possible. But if you flip a coin 1,000 times, you're going to get really, really close to that 500-500 split. I mentioned the casino earlier, right? You play one hand of blackjack at the casino, you might win big. If you play 100 hands, because ultimately the probability is in the favor of the casino, the more times you play, and there are thousands of hands of blackjack every day at every casino, the casino comes out ahead. Because mathematically, they should. And that's why they always will. Okay? So you might get lucky, but over the course of time, the more time something happens, it closer it gets to mathematically working out. Yeah? Sorry. Connor.
So you say you should own a casino?
I did not say that. What I said was, if you go and you come away a big winner because you played 2 or 3 or 20 or even 50 hands, you might have won. But in the grand scheme of things, everybody playing day after day after day, because the probability is a 51-49% split in favor of the casino, that means that on average, out of every 100 hands, the casino wins 51 of them. Over, a day, a month, a year, the casino will always come out ahead. Because the more times you play, the more hands you play, the closer and closer it gets to what should happen. You might get lucky, but that's why the casino doesn't really care. That's why they celebrate wins. Because people do win, but they win in the end. Because for every dollar that you win, that's a dollar that someone else lost. So, questions on that? Okay, so the experimental probability, what actually happens, theoretical probability, what should happen. So down here, you've got a spinner. I think yours is in black and white, so you can see which sections are red, which sections are yellow here. But it says, use the spinner below to determine if the result, pause. All right. Use the spinner below to determine if the result is above, below, or equal to the theoretical probability. So if you take 12 spins, okay, 12 spins, how many times should each number come up? You take 12 spins, theoretically, how many times do you get a 1, a 2, a 3, and a 4? Aiden?
3.
Right? 3 of each makes 12, right? Okay. You get 4 twos. Oh. Was your result above, below, or equal to the theoretical probability? Leah? Above, right? You should have gotten 3. You got 4. So your results are above what should have happened. Okay? Next one, we're looking at just the colors of red and yellow. You get 10 spins and get 3 yellows. In 10 spins, how many reds and how many yellows should you get? See, this is what I was talking about in Ms. Kasurik's class about participation, right? He's so quiet. You get 10 spins. How many reds and how many yellows should you get? Aiden?
Like 2.5 about?
Well, there are 2 reds and 2 yellows, right? It doesn't matter whether it's a yellow 4 or a yellow 2. It's either a red or a yellow. So 10 spins, 2.5 of each number, yes. But how many reds and how many yellows? We're just breaking it down into red and yellow here. Leah? 5, right? Essentially, half the spinner is red, half the spinner is yellow. So in 10 spins, you should get 5 of each. You got 3. Is your result above, below, or equal to what should have happened? Is 3 less than, equal to, or greater than 5? Less than. So you got below, right? You're comparing what actually happened, the 3, to what should have happened, the 5. Since 3 is less than 5, you got below. You take 32 spins and get 10 ones. Ooh, boy. In 32 spins, again, looking at numbers again here, so now we're back to 4 sections. In 32 spins, how many of each number should you get? "32 spins divided by 4 options." Connor?
8.
You should get 8, right? It's the total divided by how many options there are. You should get 8 of them. 8, 8, 8, and 8 make 32. You got 10. Is your result above, below, or equal to the theoretical probability? I can't say that word today. Probability. Connor? Above. Okay. Should have gotten 8. You got 10. You take 250 spins and get 120 odds. So we're back to only looking at 2 options here, right? You can get an even number or you can get an odd number. If you take 250 spins and there are 2 options you could get, how many of each one should you get? Aiden? 125. Just half and half. You get 120. What do you think? Above, below, equal? Below. Okay. You take 1 spin and you get a 3. If you take 1 spin of anything, 1 spin, 1 flip of a coin, 1 roll of a die, 1 of anything, your result will always be what? Above, below, or equal to what should have happened? Annika? It'll always be above because you only did it 1 time, right? Even flipping a coin, there's only 2 options there. If you only do it once, whatever you get is above what should have happened, right? Because you're not going to get that same thing every single time. So whenever there's 1 of something, you're always going to be above. All right. No homework for tomorrow. Have a tremendous evening. Work on practice work. We have a retake day this coming week on Friday, and I'm after school on Friday as well. That's High Math.